Hello and welcome to another tutorial video for the Industrial Robotics Framework Machining Cell. In this tutorial, I'll be covering how to actually start running the robot. So, let me get back to the HMI. So, the first thing that you need to do when attempting to run the robot is have a fully trained part. Now, I know that this part has been trained as I've done the training, so I will want to start a production run on it. As I know there hasn't been one for it already, I will begin by using the RunnRobot command. This will start a new batch of this part, which can be run in the run screen. So if we click here, we're prompted to provide an order code and an order count. So the order code is whatever the batch number or identification method that you use to identify a particular batch. If it's a series of numbers, then it can simply just be some numbers, or if you use alphabet, if you use characters, characters are also acceptable. From there, we will input how many parts are in this batch, and we will click Add Order. This will create a new order for this part, which was available to run in the run screen. A couple of things that can be noted from here. In the run screen now, which we are automatically taken to when we add the batch, we have the batch or order available down the bottom. This will show the name of the part that is being run, how many have been completed out of the total number of parts in that batch, and up the top we'll see the order code along with that same lot of information about how many have been complete versus how many are in the batch. This is now available to be run on the robot, and we can start actually performing the runs. To do so, we first must select which table it is that we are loading the parts on. So in this case, we may be running on table 1. And typically from here, you will have loaded the parts onto the table and positioned it inside of the cell, ready for the robot to scan. To run the scan, you simply click the Scan Table button, and the robot will begin running its scan procedure. While it will be shown in another video, typically this procedure will show a red box outlining, or a series of red boxes should I say, outlining any regions of interest that the robot finds on the table. It will then proceed to do a high precision laser scan across each of these, followed up by a small amount of processing time to identify what those parts are and where they are on the table. Since this is a virtual tutorial, I will simply add a part, and this will simulate the same effect. So, what will happen following a scan is the parts that are detected will load onto the table in whatever position they were identified in, and all of their respective operations will load in as well. Once that is complete, the UI will unlock, allowing you to continue progressing. What you can see here is that now in table 1 I have an associated part that has been loaded in. If I select that part, then I can see a series of operations. These operations are all of the trained operations that need to be run on this part, and will be updated throughout the course of the production run. What you will find is that as each operation is completed, the loaded term will shift to completed, and the runtime will update to show how long it took to run that particular operation. If I am finished with this part, I can then unload the table and move on to the next one. Additionally, if I attempt to scan the table again, assuming that the part has already been completed, it will automatically unload, and you will not have to press this button. To run an operation, you enter either the cold run or hot run mode, depending on which mode you're interested in using. By selecting the cold run mode, you can start running this part in the cold run state. Inside of the cold run state, the tool itself, whichever it may be, will not turn on, and the robot will simply perform the motions it would do if it was actually performing the operation. For the case of the deburrer, this will mean that the compliance on the tool available will activate, but the tooling itself will not turn on. If this was instead on the welder and the Fronius unit is in use, this will activate the touch sense mode instead, and the wire can be seen retracting and extending onto the part as it is touched. If I instead wanted to run this and do the actual operation, I would instead use hot run. For the hot run, this will perform exactly the same as the cold run, except that the tooling itself will turn on. An additional difference would be in the case of a welding unit, where the robot will also perform a temperature check of the part in this case, to ensure that the part is of a correct temperature to perform the weld. You can see here that we have a number of options available for performing the run. These options are available when selecting either a particular part or a particular table inside of the machine queue. These options specify a set of operations with which you want to run the robot for, whether or not you want to alternate operations, whether you want to move directly between operations, and whether you want to reset the positioner following a run. Not all of these options will be valid depending on which of a table or a part you are selecting, but we will go through each of them nonetheless. In the case of a start operation, this will specify which operation you want to start from. During training, each operation can be assigned to a particular number specifying its order. By setting this value, you can say from which of those operations you want to start from. So in this case, we're starting from operation 1. Ending before operation. In this case, we can specify that we want the robot to stop performing operations before a specific number. If this end before operation is equal to or less than the start number, it will continue and perform all remaining operations. If instead I increase this value to say 2 or even 3, now the robot will perform operations within the selected range. So in this case, it will start from operation 1, performing operation 1 of the part, and end before operation 3, meaning that it will stop before it gets to operation 3, and thereby do operation 1 and operation 2. Below this, we have alternate ops, or alternate operations. This is primarily used when selecting a table and allows the system to interchange between one or more parts that are on the table. In doing this, the robot will move between each of the parts, performing, say, operation 1 on every part of the table, and then operation 2 on each part of the table, rather than performing operation 1 and 2 on a particular part, and then 1 and 2 on the next part. The direct move is used so that the robot will directly move from one operation to the next. By turning this off, the robot will return to the low table position after each run. This can be used to optimize robot motion, as it will move directly between particular parts. However, caution is advised in using this in making sure that the parts have been trained such that motion between them is safe for the robot to perform. This is typically done by ensuring that the approach distance is of a high enough point that the robot can safely move between parts. When using a positioner as one of the tables, as we can see if I switch to table 3, then you can enable the reset positioner option. And what this will do is, if the positioner is off its axis or rotated down to be used for the operation, this will, at the end of the run, reset the positioner back to the 0 position. These options are available for use when selecting the table and the part. Additionally, if you select a particular operation, then you have a different parameter, being a partial operation percentage. In rare cases, particularly for welding, there are times where, say, the gas can run out or the wire can run out, and so only a partial amount of the operation was complete. In these cases, you want to be able to finish off that operation, but you don't want the welder, let's say, to turn on before that point. In this case, you can specify a partial operation percentage, which will then ensure that the tool in question does not turn on before it gets to however far through the operation. So if I set this to, say, 50, then the tooling will not turn on until such time as the robot reaches halfway through the operation. When inside of the run screen and looking to perform a particular run or set of runs, you select from the machine queue what operation or operations that you want to run. If you want to run a particular operation as a one-of, you select the operation in question and click on the hot run, ensuring first, of course, that your cell is safe and everything is ready to go. This will be explained in a later video. If instead you want to run all the operations for a particular part, or a selection of operations for a particular part, you can instead select that part on the table, put in the parameters you seek, and again hit run. If you are looking to run all the parts on the table, you will select the table itself, and again you can select the options you require, being in this case to run operation 1 and 2 for all available parts, and again hit run. Once all operations have been completed, the part itself will be noted as completed, and the batch order will update to say that another part has been completed. If at any point there is a mismatch between the numbers shown here and what has actually been done, or in the case that you need to update any information regarding the batch, say if you were to run some parts of the batch in training where they do not count towards the order, then you can use the settings button for the order to update the order itself. If I click on that, I will be prompted with 3 boxes that allow me to update the order code if I accidentally got this wrong, the completed count, say if 2 parts were completed but they weren't counted, and the order count in the case that I miscounted how many are in that order. If I click then save, you'll see that this updates and is reflected inside of the operation, inside of the window. If, say, the part was on the table but something went wrong, and say the part was accidentally moved or bumped and needs to be removed or rescanned, I would need to first unload the table. As the part is incomplete, I will be prompted to respond with why I am unloading that part. In this case, you could specify that yes, the part was complete, even though it was incomplete in this case, but there are times where a part needs to be rescanned mid-operation in case of some user error or in case of other errors within the system. So some operations may get reloaded in but not run. In those cases, you can still specify the part as having been completed and it counts towards the batch. Optionally, there are other cases where the part itself could be, where something could have gone wrong on the part, and you can specify a reasoning for needing to remove that part from the table. Whether it be that rework needs to be done, whether the part was scrapped for some reason, or whether it's just become waste. In any of these cases, the part is cancelled and still does not count towards the batch. In other cases where the part was accidentally bumped and needs rescanning, or just other cases where the part is still good to run, it just needs to be rescanned, you can use other, and this then just deletes the part and makes it not count. So we'll just do that for this case, and we can see the table unload. That will allow me to scan the table again if I needed to obtain that part. In the case that I now need to complete the batch, pause the batch, or cancel the batch, I can press the X on the batch down the bottom. This will prompt with another window in the case that, in this case, it has not been completed, and will request why we have chosen to cancel the batch. We can specify here to complete the batch and say that yes, this is actually being completed and either the count is off or it was completed elsewhere. We can pause the batch, which allows us to remove it from the screen but allows us to gain access to it later. Or we can cancel the batch and say that the batch was no longer required or something came up and now the batch will no longer be run. In this case, to show the functionality, I will use the pause batch method. You'll see here that the batch has been removed. If I want to resume that batch, I can add to order, and this will take me back to the part screen. From here, I can resume a batch, and in the drop-down menu, I can find batches that have not been completed yet, or that have been paused. In the event that the system crashes, any active batches will automatically be listed as paused on restart, allowing you to gain access to them this way. This will allow me to select the batch and start it. And now I can continue from where I left off. Additionally, if I were to add that part back in again, I can cancel that part directly in the case that something went wrong or I just needed to directly remove that singular part from the table without disturbing the rest. In the case that I am running on, say, a positioner on table 1 instead of the table, then I can use the Switch Table Type button to switch that table from a table to a positioner. In this case, it will load in the table as a positioner, and then when we scan the table again, the the simulation will update to reflect the position of that positioner inside of the system. For now, we will switch that back. In the case that I want to run a quality control scan outside of the automated quality control methods, I can use the quality control button. When using this, I either select the table or a particular part on the table that I want to run the quality control scan for, and then hit the quality control button. The robot will then perform a series of scans over that part or the parts available on the table, identify the one in which you requested the quality control, or all in the case of the table, and provide a quality control result. This will this will save inside of the system how well the job was done compared to the reference for a completed job. In the case of using other aspects of the system, say you were making use of the positioner, you can use the positioner mode to run specific commands for a positioner. The two default available commands are to reset the positioners, and this will allow you to either reset positioner A, which is the table 1 positioner, bringing it back up to straight vertical and unwrapping its rotating axis, or resetting positioner B, which is the table 3 positioner. Additionally, you can specify a positioner rotation, so this will rotate the positioner up and down to the specified angle between 0 and 90 degrees. To do so, select the table in which you have that positioner. So in this case, I might be doing positioner B, so I would select table 3, or positioner 3 in this case. I would specify the angle at which I want it to rotate to, and click on the Rotate to Position button. The positioner will then rotate to the specified angle. I could instead ask it to start continuous rotation, in which case the rotating axis will start spinning until I say stop. The stop button will re-enable when using one of these functions. If I was to instead have the positioner on table 1, I would need to ensure that I select table 1 and then use these same functions. You have also controls for performing service operations of the robot. This allows you to drive the robot manually between tables in the case that you need to manually move the robot, or perform service operations. The first options around the outside are to drive the robot to a particular table. So you can click any of these and the robot will drive to the specified table. The center button is the service table, which will allow you to drive the robot back to the service area. Within this area, you will gain access to some additional functionality based on the robot type, which could allow you to change tools in the case of the positioner, or scan the tool change station in the case that you wanted to, in the case that you changed out a tip and the robot needs to identify its new tool tip. Or in the case of the welder, will allow you to manually perform a tip clean or a wire trim. And that provides the functionality for the run screen. To give a quick review, you select which table it is that you want to run on once you have loaded in an order to the system. From there, you scan the table and the parts will appear on the table within the simulation. Once those parts have loaded, you can then begin either doing cold or hot runs, depending on what it is you are attempting to test or whether you are intending to run. Once the hot runs are completed, the parts will be noted as completed and the order will update. Once all the parts are done, they can be unloaded from the table and the next lot loaded in, performing a scan again to get these new parts. Once all parts are completed and the order is finished, you can cancel the order or end the order and set it as completed, in this case only because it hasn't actually been completed, which I will quickly update to demonstrate. And now it will automatically disappear. So by clicking the X, you will finish the order once it is completed. And that is the functionality for the run screen. Thank you.